So this question was on our test for the kinematics part 2, and I just want to talk about it a little bit and post it. So Matthew is traveling in a car at 25 meters per second. Tanya follows at 35 meters per second behind him. Tanya is behind him by 55 meters. Tanya brakes and decelerates at 2.2 meters per second until her velocity is the same as Matthew's. What's the distance between them? So we can figure out the velocity 1 of Matthew is 25 meters per second, and velocity 1 of Tanya is 35 meters per second. Logically, if you think about it, over time, if they continue at the same velocity, Tanya is going to overtake Matthew. If I'm walking, let's say I'm walking here, and I'm walking at a pace of 2 meters per second. And some person, he's running at 10 meters per second. Well, actually, that's really fast. I don't even know. I'll just say he's running at a faster pace than 2 meters per second. If I'm running at a pace like this, and he's running at a pace like this, eventually, he's going to overtake me. So that's the whole premise of this question. What if Tanya decelerates? So this doesn't mean that her velocity stays at 35 meters per second. It means that she slows down, but she's still traveling faster than Matthew in all those intervals. So one thing I could think of is find the distance between distance that they travel, that Matthew travels with his velocity, and the distance that Tanya travels while she's decelerating. Okay, so let's talk about Matthew first, since it's the easier one. So V Matthew equals 25 meters per second. All right, that's established now. Let's figure out the distance now. So displacement equals velocity multiplied by time, change in time. So it's 25 multiplied by time. And since we do not know what time is, we have to solve it. So what is time in this question? Well, time is the time that Tanya finishes her deceleration and reaches the same velocity as Matthew. Because if you read the question, it says until her velocity is the same as Matthew's. So while she's decelerating, the time that she takes decelerating is the same amount of time that Matthew travels in that time frame. So we have to figure out the time. And looking at our formula sheet, we figure out that time can be calculated through V2 and V1 and acceleration, which is perfect for our formula. So let's take the Tanya, and let's set V1 to 35 meters per second, and V2 to 25 meters per second, because she needs to stop at 25 meters per second. She needs to stop accelerating at 25 meters per second. Her acceleration is 2.2 meters per second. But hold up, meters per second. But hold up, she's decelerating. This means her acceleration is just going to be negative, because her velocity is in this direction. And if she's slowing down, she'll slow down like this. Like this. If her acceleration was positive, she would just go like that. So let's use the formula. V2 equals V1 plus A multiplied by T. So we figure out it's 25, 35 plus negative 2.2. Let's put brackets not to confuse ourselves, multiplied by time. And we get negative 10 divided by negative 2.2 for time. And use our calculator over here. Negative 10 divided by negative 2.2 equals 4.54. Repeating. Equals time. Make sure to keep this in seconds. And then now we know what time is. We can figure out the displacement of Matthew now. So it's 25 multiplied by 4.54. And that equals, multiplied by 25, equals 11.363. 11.363. And make sure to keep this in meters. Alright, so now we know how far Matthew travels in that time frame. We also have to figure out the time that Tanya travels now. So it's pretty simple, actually. We just use the same formula again, but for displacement this time. So displacement equals 1/2 multiplied by V1 plus V2 multiplied by time. And this should equal 60 multiplied by 4.54. This gives us 30 multiplied by 4.54. And then we just take our calculator again. 30 multiplied by 4.54. $136.2. So this equals 136.2 now. So what do these numbers mean? Well, we already established what this number means. Displacement of Matthew is how much he travels in that certain time frame. But what does this number mean? Well, it's basically the same thing. It's how much meters she travels in a certain time frame. So you may be asking a question, why is her displacement higher than his displacement? Well, this is depending on their location now. So if we just take these numbers as literal numbers of their displacements and we find a distance between them, we get 23. Yeah, we get 23 maybe. And if you get 23, that's the distance between them if they both start at the same time with the same at the same time at the same position in a given period of time. So this would be Matthew's displacement. And this would be Tanya's displacement parallel to him if they both start at the same distance. Wait, no, this is Tanya. That would be Tanya's displacement at the same position. So who is farther? Tanya is by 23 meters. So now we've established how far Tanya gains an advantage over Matthew. Let's figure out the main question. How far are they apart now? Well, in the beginning, they were 55 meters apart. Now Tanya gains 23 meters. She gains 23 meters. Because they both start at 0. Tanya is always going to gain 23 meters. If they start at here and here, Tanya is always going to gain 23 meters. Minus this area. Right? So what we do here is that we take 55, subtract by 23 meters. And this should give us 32 meters. And that's the answer. It's just, this question is complex if you just don't understand the kinematics formulas. So this video is mainly just to explain where we're getting all these numbers from and what these numbers mean. So yeah, don't try to remember how to solve this. Try to understand how to solve this for the accommodating in exam.